Hey buddies, welcome to my channel Study Buddy. In this channel, I'll be uploading all the solutions of CBSE Class 10 Mathematics. So let's get started with the second problem of exercise 1.2 from Real Numbers chapter. Question number 2. Find the HCF and LCM of the following pairs of integers and verify that the LCM into HCF is equal to the product of the two numbers. So they have given us three pairs of numbers and asking us to verify how the product of their HCF and LCM is equal to the product of numbers. So let's start with the first question. So 26 is equal to 2 into 13. Since you take LCM, you get these two as the factors of 26. And taking LCM for 91, you get 7 into 13. Next, the HCF of these two numbers becomes 13. I'll just give you a small trick to calculate. Here I'm taking LCM to be 2 into 7 into 13, which becomes 182. So before that, I'll give you a small trick to calculate the HCF and LCM of the two numbers. So first you have to take the HCF and LCM of 26 and 91 separately and write down the factors. Once you are done with that, for calculating HCF, you take the common factor with least power. For 2 into 13 and 7 into 13, which is the common factor? It is 13. And which is the least power? Both of them have the power to be 1 and hence the HCF of 26 and 91 is 13. Next, going on with the LCM of two numbers. For LCM, the trick is all the factors with highest power. So I'm taking all the factors 2, 7 and 13. But 13 is common. So which is having the least power? Both of them are having 1 and hence I'm taking 2 into 7 into 13. After multiplication, I got the answer to be 182. Next, since we got the HCF and LCM of the numbers, I'm taking the product of HCF and LCM. From that you get 13 into 182 to be 2366. Next, I'm taking the product of the two numbers. So 26 into 91 is equal to 2366. So equation 1 is equal to equation 2. Therefore, the product of the HCF and LCM of two numbers is always equal to the product of numbers. Let's go ahead with the second question. So finding the HCF and LCM for the following pairs, and the pair is 510 and 92. So let's start with the second question. So 510. By using the factor tree method, I got the factors to be 2 and 255. 255 is a composite number and the factors are 5 and 51. 51 is composite once again and you get 3 and 17. Now both the numbers are composite prime numbers and hence they cannot be divided further. Therefore, the LCM of 510 is 2 into 5 into 3 into 17. That is what we have written here. Next, I am going to take the factors of 92. For that, once again applying factor tree method. So 92 is 2 into 46. 46 is composite and can be written as 2 into 23. 23 and 2 are prime and therefore 2 into 2, that is 2 square into 23 is the factors of 92. So from these two equations, from equation 1 and from equation 2, I have the HCF to be 2. As I said 2 is common in both the terms. But we have to consider the least term or the least power for HCF. That is the common factor in both the common factor with the highest power. Therefore, with the least power. For HCF, it has to be with the least power. Therefore, HCF becomes 2. Next, for the LCM, you have to always consider all the factors given with the highest power. So for LCM, I'm taking 2 as the common factor among all, and the highest power among that is 2 square. So 2 square, and the remaining things are as usual. I'm taking all the factors. And since you multiply it, you get 23,460. Now multiplying the numbers, we have got the product of HCF and LCM to be 2 into 23,460 to be equal to 46,920. This is equation 3. Now taking the product of two numbers, that is 510 into 92. That is also 46,920. That is going to be here equation 4. Therefore, from this we have got that the product of HCF and LCM is once again equal to product of the numbers. That is, the HCF and LCM of 510 and 92 is equal to the product of these two numbers. So let's go on with the third problem. Third problem is calculating or verifying that how the LCM and HCF is equal to the product of these two numbers. That is, the product of 336 and 54 should be equal to the product of their HCF and LCM. So let's start with the third. So here I am taking the LCM of 336 and 54. From that I have got that the factors of 336 is 2 power 4 into 3 into 7, and the products or the factors of 54 is 2 and 3 cube. Let's go ahead with the next part of it. That is from equation 1 and 2. We got that the HCF to be 2 into 3, that is 6. I have used the factor 3 method to derive the factors of these two numbers. By using factor 3 method, you have got the above solution. So I'm taking for HCF common factors with the least power. So here the highest power of 2 is 4, but I'm taking the least one to be 2 itself. And 3 also, 3 cube is the highest one, but I'm taking it to be 3. Therefore 2 into 3 is equal to 6. That is the common factor with the least power. Therefore HCF becomes 6. Going on with LCM. For LCM, I'm considering all the factors with highest power. So 2 power 4 into 3 cube into 7 becomes 16 into 27 into 7, and therefore you get the answer to be 3024. Now the product of HCF and LCM, that is what we are supposed to do. So from that you get 6 into 3024 to be 18,144. I'm taking it to be sum equation 3. Now taking the product of the three numbers, that is product of the two numbers, 336 and the 54 is the given two numbers, right? So I'm taking the product of these two numbers and you get it to be 18,144 only. Therefore, equation 3 is equal to equation 4, and from that we have proved that the LCM into HCF of any number is always equal to the product of these two numbers. So we have completed the second problem of this exercise. In my next video, I'll provide the solutions for the remaining problems. So please do refer my channel for further videos. Thank you.